Going to start the new chapter, and that chapter is what here Newton's law of motion. I hope maybe many of them is know about the many definitions which is given in this topic or in this chapter in the previous class, either in the class 9th or 10th. But some topic I would like to repeat, or some topic I would like to remind you, like what is the force, type of the force, what is the inertia, what is the Newton's first law, Newton's second law. All these law even already have studied in the class 9th or 10th, I think. So first thing here, what here? Force. All of you know, force is that cause or that external push or pull that change or tends to change the state of rest or state of motion of the body. So simply you can say force is that cause or that push or pull which change or tends to change the state of rest or the state of motion of the body. Now, the forces is classified mainly two types. One is the contact force and other is non-contact force. And as you know, contact force, as it is clear from its name, the contact force is the force that comes into play with the actual contact of the bodies or actual contact between the bodies. For example, like normal reaction, tension force, or you can say frictional force, or air resistance, that will becomes under what type of the force here? The contact force here. And non-contact force, the force which comes into play without any physical contact of the bodies. बॉडी के बिना फिजिकल कांटेक्ट में आए हुए जो फोर्स बॉडी एक्सपीरियंस करती है वो सब क्या कहलाती है? नॉन कांटेक्ट फोर्स, जैसे इलेक्ट्रिकल फोर्स, magnetic force, gravitational force. So all these are the non-contact force. So mainly force, and which is divided into two class, contact force and the non-contact force. And the all forces which exist in the nature is either contact force or what here the non-contact forces. And the third important topic in this chapter is what here? The rule of inertia. I hope maybe all of you know the inertia is that inherent property of the body So inertia is what here? Inertia is that inherent property of the body which always opposes any change either in its state of rest or the state of motion. If the body is in rest, then it will remain in rest. Or if the body is in motion, then it will remain in motion. This inherent property developed in the body due to the property of what here? Inertia. So simply all of you know about the inertia, and also you know inertia of rest, inertia of motion, inertia of direction. So all these topics already I have studied in the class 9th or 10th here. Also you know what is the linear moment or Newton's first law of motion. And now the Newton's first law of motion. I hope maybe all of you know. According to Newton's first law of motion, if a body is in rest, then it will remain in rest. And if the body is in motion with the same speed in the same direction, then it will remain in motion unless or until an external force is applied on it. Again, addition here, according to the statement of the Newton's first law of motion, if a body is in rest, then it will remain in rest. And if the body is in motion with the same speed in the same direction, then that body is remain in motion unless an external force is applied on it. अगर कोई बॉडी रेस्ट में है तो उसका एक्सीलरेशन जीरो होगा, और एक्सीलरेशन जीरो होगा तो इसका मतलब उसके ऊपर लगने वाला फोर्स भी क्या होगा? जीरो होगा, क्योंकि फोर्स इज इक्वल टू मास इनटू एक्सीलरेशन. एंड इफ ए बॉडी इज मूविंग विद द सेम वेलोसिटी इन द सेम डायरेक्शन, then in that case here also, if the body is moving with the same velocity, then acceleration will also zero. If the body is moving with the same velocity in same direction, then its acceleration will also zero, and in that case also force will be equal to zero. So in that case you can say here that Newton's first law of motion, body is in rest, it will remain in rest. Body is in motion, it will remain in motion unless we apply any external force on it. You know, when a body is rolled on the ground, जब जमीन पे कोई बॉडी लुढ़कती है तो देखते होंगे थोड़ी देर में वो रुक जाती है, जबकि उसे तो चलना ही चाहिए था. क्यों रुक जाती है? Due to the frictional force of the ground or due to the frictional force of the earth. अगर ये धीरे धीरे हम फ्रिक्शनल फोर्स को कम करते जाएं तो बॉडी ज्यादा दूर तक रोल करती जाएगी। एंड सपोज इफ यू रिड्यूस द फ्रिक्शनल फोर्सेस कंप्लीटली, अगर ये फ्रिक्शनल फोर्स हम कंप्लीटली हटा दें, ये बॉडी लगातार लुढ़कती ही रहेगी, इट विल नेवर कम्स इन रेस्ट। Why? Due to the Newton's first law of motion. Next topic is linear momentum, and by definition, the product of mass and the velocity of the body is called the linear momentum of that body. And suppose a body of mass m moving with velocity v, then its linear momentum is given by p is equal to m into v. And remember, this momentum is a vector quantity, so it has the both magnitude as well as direction. How much the magnitude? Magnitude is equal to the product of magnitude of mass and velocity, and direction of this linear momentum is same as the direction of motion of the body here. The SI unit of linear momentum is kilogram meter per second, and its dimension is mLt to the power minus 1. So in this way you can say the definition of this linear momentum, unit of linear momentum, and dimension of the linear momentum. Suppose a car of mass m1 and a truck of mass m2, and here m2 is greater than m1 means mass of the truck is more than the mass of car, are moving with the same velocity v. इसका मतलब a car of mass m1 and a truck of mass m2 both are moving with the same velocity. If p1 and p2 are the linear momentum of car and truck, then you can say linear momentum of car p1 is equal to m1b and linear momentum of truck is m2b, and their ratio, if you find out, p1 upon p2 is equal to m1b upon m2b, or simply you can say p1 upon p2 is equal to m1 upon m2. Now you see, since m2 is greater than m1, m2 is greater than m1. If m2 is greater than m1, then you can say p2 is greater than p1. p2 किसका था linear momentum? Truck का. It means if a car and a truck, it means a heavier body and a lighter body, if both are moving with the same velocity, then the linear momentum of heavier body will be more. तब लीनियर मोमेंटम जो हैवियर बॉडी का रहेगा वो क्या रहेगा? वो ज्यादा रहेगा. Also you can think like this one here. Suppose if we will take a car and a truck, and suppose both moving with the same velocity, and when collide with any body, किसी चीज से टकराएगी, तो कार ज्यादा डैमेज करेगा या ट्रक? तो बट नेचुरल है, ट्रक जो है वो ज्यादा डैमेज करेगा उस बॉडी को कंपेरेटिवली टू कार. क्यों? क्योंकि ट्रक का क्या था? मोमेंटम ज्यादा था, इसलिए वो ज्यादा फोर्स भी लगाया होगा उस बॉडी के ऊपर. तो सिंपली यू कैन से इफ द टू बॉडी हैविंग डिफरेंट मास traveling with the or moving with the same velocity, then the heavier body will always produce the greater momentum. Now again, if we consider now a car of mass m1 and a truck of mass m2 moving with velocities v1 and v2, but their linear momentum are same. अगर एक कार और एक ट्रक जिसके मास m1 m2 हो, उनकी वेलोसिटी v1 v2 हो, and both is moving with the same linear momentum, then you can say linear momentum of the car is m1 v1 and linear momentum of truck m2 v2. Since their linear momentum are same, so you can say m1 v1 is equal to m2 v2, or from here you can say v1 upon v2 is equal to m2 upon m1. अब देखिए, since m2 is the mass of truck and m1 is the mass of car, so if mass of truck is greater than the mass of car, m2 is greater than m1, or if m2 is greater than m1, it means if numerator is greater than denominator, then this ratio becomes always greater than 1. So you can say v1 upon v2, v1 upon v2 is greater than 1, or you can say v1 is greater than v2. It means v1 is the velocity of car, v2 is the velocity of truck. It means if a lighter body and heavier body both are moving with the same linear momentum, then the velocity of the lighter body is more than the velocity of the heavier body. So in this way also you can find out the relation between the velocity if their linear momentum are same, or if their mass is given, their you can say here their velocity is given, then also you can find here which one will produce the more linear momentum. So simply you can say the concept of the linear momentum, or you can find out the linear momentum of a moving body by using this formula simply. Now, some important points about the momentum. And first one is what here, formula for the linear momentum P is equal to mv. And for a given body, its mass is remain constant. एक दिए गए बॉडी का मास तो कांस्टेंट रहेगा. तो फॉर ए गिवन बॉडी इफ m is constant, अगर मास कांस्टेंट है तो p is directly proportional to p. It means when you will draw a graph between linear momentum and velocity, since p is directly proportional to v, so the graph between p versus v, you will get a straight line graph. Huh? And this will be what here, under this mass is what here remain constant. And you can say P upon V. Suppose this one is given and this one is a straight line. So when you will find out the slope of it, P upon V, then that slope will give the mass of that body. So simply you can say here is the graph between P versus V is what here a straight line. Second case, when momentum remain constant. पहले हमने क्या constant किया था? In the first case, you have taken when mass is constant. Now, when the momentum is remain constant, P is equal to constant. It means, P is equal to mv. So, mv is equal to constant. And when mv is equal to constant, then you can say v is inversely proportional to m. जैसे हम कहते हैं tv is equal to constant, तो p is inversely proportional to v. उसी तरह से if mv is equal to constant, so you can say v is inversely proportional to m. It means a graph between V and MV versus M is what here. This one is called rectangular hyperbola graph. This one is V is inversely proportional to M. And third case, when the velocity of the moving body is remain constant. And if the velocity is constant, then you can say V is equal to constant. And V is equal to constant means you can say P is equal to mv, or P upon M is equal to V, and V is what here constant, so you can say P upon M is equal to constant. And if P upon M is equal to constant, then you can say P is directly proportional to M. It means a graph between mass and momentum, or when you will draw a graph between mass and momentum, then it becomes a straight line because this one is a directly proportional. And when you will calculate the slope of this graph, P upon M, so you will get the velocity V, and that velocity is remain constant. So in this way you can draw the graph for the different cases here. Either first case mass is constant, or second linear momentum is constant, or third case here when velocity is constant. So on the nature of the graph, or by the nature of the graph also you can find out if from this graph which quantity is constant in this linear momentum. So today all of you go through this topic here, what I have discussed in this chapter, and next day I will give the next topic. Thank you.